Hi and welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to describe and explain how the reactivity of group 7 elements changes down the group. You should then be able to describe how a more reactive halogen can displace a less reactive halogen from an aqueous solution of its salt. This all sounds a bit tricky, but I can tell you that it's not. Stick with it and you'll get it. In the last video, we saw that when group 7 elements react with metals, the group 7 element gains an electron to achieve a full outer energy level. So here's fluorine reacting with lithium. You can see that the fluorine atom gains an electron from the lithium atom. Now here's one really important fact. The negative electron is attracted to the positive charge of the nucleus. If we go back to group 7, we can see that fluorine is at the top of the group. Fluorine is the most reactive element in group 7. The elements get less reactive as we move down group 7. You need to learn that, and you also need to learn why. To understand this, we're going to compare fluorine with chlorine. So here they are. As we said, when they react with metals, the halogens gain an electron. Chlorine gains an electron less easily than fluorine, and there are two reasons for this. The first reason is that there's a greater distance between the outer energy level and the nucleus in chlorine than there is in fluorine. Also, in chlorine, the outer energy level is shielded from the positive charge of the nucleus by these internal electrons. Both of these factors reduce the attraction between the outer electrons and the nucleus. This means that it's harder for chlorine to attract an electron into its outer energy level than it is for fluorine. So chlorine is less reactive than fluorine. As we move down group 7, the increased distance and the increased shielding means that the elements get less reactive. Here's one last key fact. A more reactive halogen can displace a less reactive halogen from an aqueous solution of its salt. We're going to look at the reaction between the compound sodium bromide and the element fluorine. The sodium bromide is an aqueous solution, and that means that we've dissolved it in water. Now, in order to work out what happens, we've got to look at the reactivity of the halogens involved. Remember that the halogens get less reactive as we move down group 7. So we can see that fluorine is more reactive than bromine. That's because fluorine is higher than bromine in group 7. This means that the fluorine can push out or displace the bromine like this. This is called a displacement reaction. You need to be able to work out any displacement reaction that you could be given. So let's look at a couple of examples. Try this one, potassium iodide plus chlorine. You can pause the video now if you need to. We can see that chlorine is higher than iodine in group 7, which means that chlorine is more reactive than iodine. So the chlorine displaces the iodine like this, and we make potassium chloride plus iodine. Here's another one to try. Lithium chloride plus bromine, and you can pause the video now. In this case, we can see that bromine is lower down group 7 than chlorine, which tells us that bromine is less reactive. This means that bromine cannot displace chlorine, so we get no reaction. You will find plenty of questions on the group 7 halogens in my revision workbook, which you can get by clicking on the link above. Okay, so hopefully now you can describe and explain how the reactivity of group 7 elements changes down the group. You should then be able to describe how a more reactive halogen can displace a less reactive halogen from an aqueous solution of its salt.